in order to maintain the fungus. They're made of chitin. We've talked about this several times. That is a modified polysaccharide that contains nitrogen. So here is something that I want to give you a minute to talk about with your neighbor, which is these cell walls of the hyphae are thinner than plant cell walls. I would like you for a minute to talk with your neighbor about why that might be useful for a fungus, given what you know right now about the hyphae.
To absorb more nutrition.
I like that. I like that. Yeah. That's true. So, what I've got here, and it sort of goes into this, is it helps prevent them from swelling and possibly rupturing when water flows in by osmosis. So, to these points, if a fungus is trying to bring in nutrition, sugars, minerals from the environment, water is going to follow in by osmosis, right? So it gives it, the chitin gives it some structure, but it's thinner. It's able to absorb, and it also prevents them from rupturing. Anything I need to add to the physics of that? Okay, so one thing that's going to come back into play here is bulk flow, everybody's favorite thing. This came up on your quiz, probably going to come up on another quiz. Bulk flow here is the key to transport. And so the idea here is that, similar to what we've talked about before, the differences in the turgor pressure are what are going to drive bulk flow. So similar to flow and transport in plants. Here, one thing to note also is the septum So you can see that, right? You can see the cell wall within the hyphae, and then you can see that these cells are divided by septa. And there's also a pore there as well. The book talks a little bit about protecting the fungus from injury, and it says like it can get plugged, like it'll plug the septum. Do you want them to know anything more than that?
So I think a general thought about fungal structure and the hyphae structure is that there are some fungi that have the septum, and then there are some that don't. They've done away with the septum. And so what it is, it's a trade-off. So clearly there's not one absolute advantage. So some fungi, what would be the case of a fungus that is multicellular, but there are no cell divisions between them? What would we call that condition? There's a funny word that we learned earlier. It starts with a C. Cenocytic. So some fungi are cenocytic, some retain the septum between them. So what are the disadvantages and the advantages of each? Because if both are still in existence, there must be some cases where it's useful, some cases where it's not as useful. So you just said, if there are a septum in place, if there's a septum in place, you have the potential to block it off. If one part of the body has a problem, maybe it's a viral infection, viruses can infect anything. Well, if you have septa that are separating different parts, you could plug the pore and then isolate the infection. But what is the cost of having a septum there? What are you limiting by having those divisions? What's the advantage of being cenocytic? What's that?
More proteins.
Not necessarily more proteins. So if there are no divisions between the cells, what's easier to accomplish? Communication, transport. It's easier to distribute materials throughout the body if there's no separation between the cells. So there's a trade-off here. And so some lines of fungi are taking one side of the trade-off, some are going in a different direction. This is one of the, again, fundamental ideas in biology, that when people first learn about evolution, say natural selection, survival of the fittest, there is no absolute fittest. There's a fittest for a particular time and place and environment. For some fungi, the best condition is to keep the septum in place, but with pores, so you still have some communication. It's not as good at communication as if the septum weren't there at all. There's more flow if there's no septum. But those fungi that have chosen that path are now more prone to infection. So if an infection infects one part of a cenocytic organism, it's everywhere. There's no way to stop it.
I have a follow-up question for you, but I'm going to hold on to another slide. Okay, so bulk flow, we sort of talked about this essentially right now. So why is it so important to fungi? And again, going back to some of what Dr. Brewer was just saying, is that you need to be able to distribute materials throughout the organism, and especially for fungi, because the way they're getting nutrients is by growing these hyphae, then you need to be able to get the nutrition to the end of the hyphae to continue to proliferate. Additionally, the reproductive structures also need to be maintained. So these organisms need to be able to have a system to get the materials that they need to those structures. So here's where my follow-up question is going to come. So with yeast, some of you probably have experience with yeast in different ways. Hopefully they're positive. They're not always. But yeast are single-cell fungi that are found in, I'm not going to say the word, nutrient-rich environments. That was for you. So here we go. So hyphae were lost several times over evolution. So that means that when we're talking about hyphae, not all fungi have hyphae.
Right.
So then, theoretically speaking, from an evolutionary perspective, the advantage for these then are...
So what is the advantage of a single-cell organism versus a multicellular organism? Maybe this is one of those talk to your friends about. Maybe you guys should talk to your friends about why do you think single cellularity would have evolved in this group of fungi? And we're talking about organisms that are generally multicellular eukaryotes, but there are groups of fungi that are single cell? Why do you think that might be? Speak to your friends. Come up with some ideas. Maybe they've got some ideas they want to share.
What are your ideas? Why? What are the advantages? How did you phrase that? What is the advantage of unicellularity?
Yeah, so if the ancestor was multicellular, in some lineages of fungi, the ancestor of the yeast. And again, one thing to think about is the yeast, it's kind of like the term protist. Yeast is not a phylogenetic group. There is not one lineage of yeasts. Yeast is just the term we give to single-celled fungi. So there are different phyla of fungi that can have some yeast in them, and even within the phylum of Ascomycetes, there can be different groups of yeast that aren't directly related to each other. So why would it be an advantage to go from a multicellular state, in this case, back to a single-cell state? What are the advantages of being multicellular for a fungus? And what are the disadvantages? Search for food. So being single cell, is that an advantage or a disadvantage? What kind of food do fungi get? They're often decomposers. So what that means for where they live is they often live on or in their food. That's where you find fungi. They will only survive on or in a food source. That's not the nature of animals. That's the nature of fungi. So the single cell, does that provide an advantage if you have to live on or in your food? Potentially. You're smaller, one thing. What about for absorption? For absorption, what is the key feature that you're looking for? It has something to do with